Welcome to the Destiny of Manufacturing podcast, brought to you today by the Precision Metal Forming Association and the PMA's Educational Foundation. We thank them for their sponsorship and involvement with this podcast. Today, we have a special guest today from Stratasys. We have Scott Sevcik. He is the Vice President of Manufacturing Solutions. Welcome, Scott.
Hello, thanks for having me.
Thank you, sir. We appreciate you being here today. Our Destiny of Manufacturing podcast focuses on the view of a 5-year out kind of vision of where you think the industry and specifically Stratasys will fit into that picture. If you don't mind, for those that don't know, if you wouldn't mind giving us a little bit of your background and how you came to be involved with Stratasys.
Absolutely. So my education and early career experience was all within the aerospace industry. So started out as an aerospace engineer in design and systems engineering roles and later project management roles throughout a number of different corners of the industry, from very defense-oriented in missile defense programs, satellite launch programs, surveillance and reconnaissance aircraft, and then moving over more towards the commercial side and being able to work on business jets and large commercial aircraft, putting different sensors and systems on those vehicles. From there, I came to Stratasys, which represented an opportunity to really change the way vehicles were manufactured in aerospace, apply a new technology in a new way to an industry that is continuously looking to push boundaries. So that brought me here to Stratasys, and of course Stratasys is a leader in 3D printing. Been around for almost 30 years, the originator of one of the most prevalent 3D printing technologies in fused deposition modeling. And Stratasys also uniquely strong in the industrial space. So a leader in rapid prototyping, but with unique capabilities that have allowed us to push very deeply into manufacturing really over the last 10 years, from tooling applications to parts on airplanes and rockets.
That's excellent. I think that Stratasys is obviously known throughout the additive world. I don't know if all of our community knows where and how additive is of value. It's certainly gained a lot of traction over the years in the tooling areas, but I see it coming from the maintenance standpoints of companies that this can fill in a whole lot of different blanks for people. And I think everybody is really excited about where the materials are going to take us in the future and where the technology is going to take us. I'm really excited about this, and we really do appreciate you taking some time to be with us today. I want to ask you...
Absolutely. It's something.
Thank you. One of the aspects, obviously, we talk about here is your 5-year view. What would you say are some of the things, the changes that you see on the horizon that will be commonplace come 5 years from now?
I would say we have seen a shift over the last 2 years, principally, that will continue and really continue to accelerate over the next 5. So rapid prototyping still is the heart of what 3D printing does in the world today, and that is still strong, and we expect continued growth in that space. But the shift, as you were just describing, in terms of the value that's being found with rapid tooling, as well as some of the early inroads into production applications, I think that's the piece that we're going to see really strengthen considerably over the course of the next several years. We have customers that have, for a number of years now, been using 3D printing for rapid tooling, but in many cases, it hasn't been widely publicized, it hasn't been widely known. A lot of organizations don't even realize what they spend on tooling. And as the use of 3D printing in that space becomes more known, I think we'll see more and more people recognize return on investment and the significant supply chain flexibility that is offered by printing for rapid tooling. So that I see growing quite considerably, and I think in 5 years we're going to be talking about rapid prototyping and rapid tooling at the same level, instead of rapid prototyping being so much more significant in terms of the size of the 3D printing use in the industry. So really that ubiquitous use of 3D printing for tooling, I think we'll see over the course of the next several years. And the other piece is on the production side, where we're actually printing parts, bypassing tooling and putting the parts we print on vehicles. That's something that has started. There are a number of airplanes and launch vehicles and a few automobiles that are out there with 3D printed parts today. But we're still facing a significant regulatory hurdle. There's still a lot of work to do on characterization and qualification. And as that work completes, and it's work we're heavily engaged in right now, I think we'll turn a corner on production applications as well, and we'll see more and more parts printed on vehicles in 5 years, considerably more than we see today.
That's incredible, because I think most people that have been involved in additive since the beginning see this change, but one area that most people have realized it as is that the speed of which the technology goes and how quickly you can make parts hasn't lent itself to switching from prototyping to a full-blown manufacturing. What do you see changing in these 5 years to improve that, either in materials or in technology or in the actual machinery itself?
There's changes in a number of places, and one of them is a mindset. I would say over the last several years, a lot of people have been looking at a part and saying, can I print this part instead of how I'm manufacturing it today? And that's really the wrong approach. Where we're seeing the opportunities for production part printing for vehicles, it's not about a part that's there and swapping out for a printed part, because like you say, the speed for that, especially when we're talking large volume vehicles, it just doesn't make sense. If there's a cost-effective way, an economical way to produce a part, and you're happy with the part, I wouldn't convert it to printing. I think where we look at production parts from a printing context are in the applications that can't be produced another way. Where we see a lot of a real interest is where you can consolidate an assembly into a single part, where you can redesign a part to take significant weight out of it. Where the part really can't be produced another way is where we see the significant advantage on the OEM side. So the parts going onto the vehicles initially. On the aftermarket, in the MRO space and aerospace, where the economics are considerably different, and there's investment in long-term inventory of multiple different configurations, or expediting parts all around the globe to get an aircraft back in the air. The economics in that space are so dramatically different that a part that is more expensive on a one-for-one basis may make more sense in that context. So when you can go towards not stocking parts, when you can go towards a digital inventory and zero physical inventory and produce the parts when you need them, then yeah, the individual part cost may be higher, may be slower to produce, but when you look at the total ownership cost, when you look at the economics of the entire workflow, we actually see some really compelling arguments for part production there.
Yeah, that's one of the areas that I certainly was really passionate about seeing a change in, is that reducing downtime through taking these files that potentially somebody makes for the machine. Okay, all the parts are converted to a digital format, and somebody on the other end, when the machine is down or the plane or aircraft is down, what you do is you can quickly go over, print this file, and have the plane or the aircraft back up in a much reduced time, and you reduce your inventory greatly. In the long run, saves you a ton of money, and I think that's great. I'm certainly looking forward to that. Tell me a little bit about how you think Stratasys will change in 5 years to meet these new demands.
I think that change is already well underway as we have shifted more and more emphasis to the manufacturing applications. seen a much greater degree of specialization as we focus on manufacturing. So going back, when we produce equipment and materials for rapid prototyping, it's a general application. It's an application that, regardless of your industry or your background, you need similar capabilities, and we have worked hard to excel at those capabilities and ensure we're bringing the best capabilities for prototyping across all markets. When we look into manufacturing, though, the way parts are produced, the types of operations that happen on the factory floor, they're different and they require different needs. So I think what we have seen within Stratasys very consciously, and something that will progress over the next 5 years to continue here, is further specialization in terms of the products we bring to market. So we will still be bringing top-notch rapid prototyping equipment to market, but we'll also be bringing products that are focused on tooling applications, whether it's composite layup tooling or manufacturing aids or thermal forming tools or metal forming tools. More specialization in the products that we bring for those applications in tooling and in production parts. A product or a printer that produces aircraft interior parts needs to be one thing. If it's producing medical models for hospitals or for medical schools, that printer, that system and that solution is very different. So as we move more specifically and more aggressively into these manufacturing and production spaces, it's the specialization and the specificity that really evolves for us.
Great. As far as what you see, you mentioned a little bit earlier that you have to somewhat change the mindset that we have out there for how people think of things, how they think of this process and the value that it brings. What challenges do you think that there are out there in overcoming that?
So there's a number, I would say. There is some that are structural and some that are, I would say, more readily addressable. So we look at a aerospace company, for example, and how they buy parts. They know how to buy parts. They are companies that have evolved over time to be very integration focused. They're essentially supply chain and logistics companies. They know how to get parts from all different companies, all parts of the world, and bring them together and put a vehicle together. When they start looking towards technology buys as opposed to parts buys, that can be challenging. That can be a new environment for them, especially with additive manufacturing, where you are affecting more than just the part that is purchased. So it comes back to that question of the part for part cost comparison, and where you have a person making a decision at a procurement level. Well, that part costs more, so if that's what I'm being judged on, I'm going to buy the less expensive part. And having to step back from that, take a broader look at, yes, from a part for part standpoint, it is costing more, but you're saving downstream in the workflow, you're saving upstream. You're not buying the tools. Maybe that's a different buyer. So that person is making a decision in a different space. On the upstream side, it's impacting their customers, the operators, long-term operating costs by being able to digitally stock the part instead of having to physically stock them. So it requires a step higher in view as you adopt this technology. And the decisions where they're made today within many industries really have to be elevated. There has to be a executive level engagement or awareness in order to drive that broader look and being able to see the forest for the trees and understand where and how a integrated technology like this really impacts the overall life of the product or the total ownership cost. So that one is significant. And then the other one really comes down to education. An industry of people like me who didn't grow up with additive manufacturing. We learned different tool sets, we learned different manufacturing technologies, and our whole thought process around design is shaped by the technologies that we know and understand and know how to use and know how to design for. So we have, in the longer term, a fairly easy path there because today the students are learning about 3D printing. They are exposed to additive manufacturing early in their education and thinking about how to design for it. What we have, though, over the course of the next few years is this need to retrain and bring new design tools and new analysis tools that help bridge that gap and help put the tools in the toolbox for our design engineers and for our manufacturing engineers and operations managers, so that they understand what they can get out of the technology, even though it's new to them.
Gotcha. You hit on one point there earlier that really kind of tied in with a lot of what I see out there over the last 10 years, which was when it came to tooling, you had a lot of people that did not have a really good handle on the total cost of ownership of that tooling. They were bringing in tooling from overseas, and one of the challenges was that they never realized at that time what that cost really was of the tool. They had to rework it, and that wasn't being gathered. So for quite a while, people realized that we've got this great savings on tooling, but the real aspect that was a challenge was that you had to rework it once it got to your door. And do you see that this option of working on tooling as an additive process can help to, number one, to get a better handle on your total cost of ownership, and number two, reducing your downtime?
Yeah, and I think a key piece with that is also as we look towards tooling for repair scenarios. So repair, by definition, is low volume, and where you have to go out and tool for a specific repair and you don't get the opportunity to amortize that tooling cost like you do when you're in more of a mass production mode, your repair is incredibly expensive, especially when you need to move fast and you need to expedite that tooling production to affect the repair. Having additive as an option, being able to very rapidly think through your tooling approach and produce the parts you need, and if they're wrong, a day or two later have them redone, the impact on tooling for repair, both from a timeline standpoint as well as from a cost standpoint, really can be tremendous.
Great. Do you think that you've had a better time finding people in our industry when it comes to a workforce? Have you had the same challenges that most companies have with finding good people?
I think our challenges, everybody's got challenges getting the right people on board, without a doubt. I think our challenges are probably a little different from some others, whereas we kind of have an advantage in being a cool technology. When we're going out to post for a position, we generally can attract a lot of attention. And just recently, we posted for an entry-level application engineering position, and we had PhDs applying. So we do have a bit of that coolness factor and a recognition of something impactful that we can do. We also end up with a little bit of a downside in that we're in Minnesota, and unless you have been here or are from here or read all of the surveys saying we're one of the best places to live, you might view us as flyover country. So we've got always a challenge to draw in some of the advanced technical skills that are more readily available on the West Coast and the East Coast, just by where we are. But wherever we can, we're leveraging a very strong local workforce here, and that coolness factor does help bring some of the great skill sets that we need to advance the technology further into Minnesota. And then they find out how great it is, and then they tell their friends. So that'll work out for us.
Great. Yeah, I think that the engineers that I talk to at some of the colleges, they are certainly attracted to the technology because it does have that coolness factor. It does. They know that they can. It really allows them to leverage their creativity and artisticness that they have within them, and it allows them to bring that out in a different manner that you could use in many different ways. I just love it myself, and I think that a lot of the students, whenever they do a demo of a 3D printing, they just go crazy. Can you tell me a little bit about, if you look at 5 years out, what do you see that your customers are going to be asking you to do to close the loop for training their people? For instance, we have a lot of times where companies say, we have trouble attracting a high level workforce in metal forming as a whole, let's say, and they're looking to find ways to make it easier to learn the equipment. Have you guys looked at different ways to make this technology easier for let's say a high school graduate level versus an engineering graduate level?
Yeah, absolutely. That's really something we've put a lot of focus into, actually. So going back to some of the early adoption of the technology in manufacturing spaces, it was a lot of hands-on work from a team here at Stratasys. So close engagement with our customers, really collaboratively developing the applications. As we've become more and more advanced and those are more widespread, we started doing fairly simple things, such as developing design guides so that we could capture the higher end expertise and not require that deep interaction on every single opportunity. So we built design guides for key applications or challenging applications, and that gives us a better ability to help educate the workforce. What we've done beyond that now is really start pushing towards more and more services activities. So building up an organization within Stratasys that allows us to really offer training capabilities and even design assistance capabilities so that we can help a workforce that may not be trained in the technology or may not even be familiar with the technology really come up to speed fast. We've also been working with software. So we have our own software capabilities in-house as well as the different CAD and CAE and CAM companies that are throughout the industry. We've been working to push our software to better encapsulate, better provide that application-specific expertise, as well as interface with those partner CAD and CAM companies so that the design tools that are out there better reflect the process and are better able to leverage it. So for us, it's across the board in terms of different ways of getting that knowledge out there. And we'll see it continue to build. We'll see certification programs that are specific to different technologies and specific to different applications. We'll see more software development that offers very specific and specialized capabilities for different applications. And we've already seen aspects of that resonate within industry. Just very recently, we announced a collaboration in Colorado where a technical school, Metropolitan State University, installed a Fortis 900, so a very high-performance piece of equipment from Stratasys, specifically for training students on using the technology for composite layup tools. And that was funded by Lockheed Martin. So we have an aerospace company going to a technology school where they draw talent from and really bringing in that technology. And we're supporting with the technology and we're supporting with the curriculum and based on the design guides we've done to really help build those training programs. And I think that example, it's a recent one, so it's fresh in my mind, but it's something that we'll be replicating. We'll see a lot more of because the interest is there across the board. The OEMs, the manufacturers, need these skill sets. They want that training to occur, so they're going to help the schools move forward with that training, and they need us to play a role in that as well. Bring that expertise and bring the capabilities and help push the capabilities further forward, so that they can end up. So a company like Lockheed Martin can have trained staff walking in the door and knowing how to use 3D printing for composite layup tooling.
Yeah, I think that it truly is. Going forward needs to be a partnership that we really strengthen, that we have companies, technology, and education all tied together. I think that that's great, and I look forward to it. Scott, thank you so much for your time today. I wish we had longer, but we try to keep this to around the 25-minute mark, and we do appreciate you. And thank you to Stratasys for taking the time today to be on this podcast. Again, the Destiny of Manufacturing podcast is brought to you by the Precision Metal Forming Association and the PMA's Educational Foundation. We thank them, and we thank you, the listener. Have a great day.